All right, students, Assalamu alaikum. Today we're doing IGCSE Chemistry Paper 2, February March 2025, Variant 2. All right, so let's start with the first question. The diagrams show containers of gas at same temperature. All containers have the same size. Which container contains gas at the highest pressure? All right, so which of these container contains the gas at highest pressure? Okay, so pressure is directly proportional to one volume, then it is also proportional to temperature. Okay, so over here you can see that the volume of all the containers is the same, they are all the same size, right? Similarly, they have the same temperature, so neither the volume nor the temperature. Then what is the pressure also directly proportional to? Pressure is also directly proportional to number of particles. All right, pressure is directly proportional to number of gas particles. Right, that is also something. So which one has the highest number of gas particles? You can see in option A, it has the highest number of gas particles. Next question, a cooling curve for a substance is shown. All right, which statement is correct? Before we start talking about any statement, we can see that this is cooling. All right, this point is cooling from U to V. All right, then from W to X is also decrease in temperature, that is also cooling. And from Y and Z, that is also decrease in temperature, that is also cooling. All right. So between them, there are two flat lines. That means there would be changes of state. Like at this point, something is a gas. All right. At this point, it is a liquid. All right. And then at this point, the substance should be a solid. All right, and then the flat line should be going from gas to liquid. This should be condensation. All right, and x to y, this should be freezing, right? These are the changes of state that we need to know about. We need to identify all this from the graph. Okay, next, which statement is correct? Between u and v, the substance is condensing. Nope. Condensation takes place, or change of state takes place, when temperature is not decreasing. So between u and v, temperature is decreasing, so state is not changing. All right, between v and w, heat is being absorbed. Nope. The whole curve, heat is being lost. All right, excess heat is being lost, heat is not being absorbed. If heat was being absorbed, then there would be a upward gradient, but there is no upward gradient. So this statement is also wrong because of the word heat is being absorbed. It could have been correct if you said heat is being released. All right, this is also wrong. Next, between W and X, the particles are close together and randomly arranged. Between W and X, the particles are close. The particles are first of all liquid. All right, and what is the characteristic of liquid? Are they close? Yes, they are. And are they randomly moving? Yes, they are. So this statement is correct. C should be the correct answer, but let's just look at D. Between Y and Z, the substance is changing from a liquid to solid. Y and Z, the substance is already solid. Now it is cooling down. All right. Substance is changing from liquid to solid between X and Y. Okay. Next question. Samples of four gases are released in a room at the same time. The gases are carbon dioxide, CO2, hydrogen chloride, HCl, hydrogen sulfide, H2S, nitrogen dioxide, NO2. Which gas diffuses faster? The one with the least mass. Carbon dioxide, we should remember, as a mass of 44, all right, because it is CO2, right? I'll write it for you as well. CO2 has a mass of 44. All right. Basically, one carbon has a mass of 12 and two oxygen 16 plus 16. So 12 plus 16 plus 16, that is 12 plus 32, meaning 44. Okay. Next, we have hydrogen chloride. Hydrogen chloride, HCl. So chlorine has a mass of 35.5. Add 1 to it, 36.5. All right. Hydrogen sulfide. Hydrogen sulfide, they've given the formula H2S if you did not remember. Otherwise, basically, you should remember. All right. Sulfur has a mass of 32. Two hydrogens means it has a mass of 34. Nitrogen dioxide. Nitrogen dioxide is NO2. Nitrogen dioxide being NO2, meaning it has a mass of 32 oxygen and 14 nitrogen. So 32 and 14, that is 46. So which gas is the lightest? This one, right? So this is the lightest. This should have the fastest rate of diffusion. All right. So for question number 3, it is C. Next question then. 1 second. All right. Next question. Question number 4. Sulfur atoms can form negative ions S2 minus. 3 other atoms or ions are listed. All right. Argon, that is an atom. Calcium, that is also an atom. Oxide. How many of these atoms or ions have the same electronic configuration as S2 minus? So for that, we have to write the electronic configuration of S2 minus. So S had 16 electrons, 2 minus means it has gained electrons, now it has 18 electrons, right? The electronic configuration of 18 electrons is 288. Argon naturally has 18 electrons, so its electronic configuration would also be 288. All right, and then we have calcium. Calcium has a total of 20 electrons, all right, meaning it has an electronic configuration of 2882. And oxide, basically oxygen has a total of 8 electrons, minus 2 means it has gained 2 electrons, so now it has 10 electrons, so it has an electronic configuration of 10. So the only electronic configuration that matches is of argon, meaning only one of these atoms or ions has the same electronic configuration as S2 minus. All right. Next question. Element T has two isotopes, 1260 and 1460. Which statement about these isotopes is correct? First of all, this T is actually carbon because carbon has 6 protons. All right. They have different chemical properties because they have different number of neutrons. That is absolutely wrong. They have different physical properties, not different chemical properties. Next, they have the same chemical properties because they have the same number of outer shell electrons. This statement is 100% correct. We don't even have to look at other statements. This is a textbook statement. All right. Lithium is in group 1 of the periodic table. Nitrogen is in group 5 of the periodic table. Lithium reacts with nitrogen to form the ionic compound lithium nitride Li3N. All right. What happens to the electrons when lithium atoms and nitrogen atoms form ions? Lithium atoms, each lithium atom loses 1 electron to form Li plus ion. That is very correct. This statement is very correct. Lithium will lose 1 electron per atom. All right. Next, each nitrogen atom gains 3 electrons to form N3 minus ion. This statement is also very correct. All right. So the answer should definitely be A. Okay. But let's look at the other ones. Each lithium atom loses 1 electron to form Li plus ion. This is also correct statement. Each nitrogen atom gains 5 electrons. That is wrong. It doesn't gain 5 electrons. It just needs 3 electrons. It gains 3. Okay. Next, we have each lithium atom gains. Wrong. Lithium atom always loses. Each lithium atom gains. That is also wrong. All right. Next, for which covalent compound does the dot and cross diagram correctly show the outer shell electrons? All right. So, which covalent compound is the diagram correct? Obviously, it is not A. These two electrons do not belong to hydrogen. It is not B either. Hydrogen only has 1 electron, which it shares, right? It shouldn't have any of those. All right. C looks 100% guaranteed correct. Why? Because as you can see, nitrogen has 5 electrons, 3 of which it shares, and 1 lone pair. All right. And then each hydrogen is sharing 1 electron each, and they don't have any other electrons. So C is 100% correct. All right. Question number 8. Which row identifies the positive and negative particles present in a giant metallic lattice? Positive particles, negative particles. All right. And giant metallic lattice. Okay. 1 second. In a giant metallic lattice. Okay. So you have to focus on the fact that it is a giant metallic lattice, not an ionic compound. In a giant metallic lattice, we have positive metal ions, right? We have what? We have positive metal ions surrounded by a sea of delocalized electrons. Positive metal ions surrounded by a sea of delocalized electrons. All right. So that is what it is. Okay. Now next, positive particle meaning positive metal ions, which are cations. All right. So answer could either be C or D. But now because it is a giant metallic lattice, the negative one could not be anion. All right. Anion could not be. So the correct answer would be cations and delocalized electrons. All right. Next, which formula for the named compound is correct? Calcium oxide CaO, this is correct, right? Calcium oxide CaO is correct. Why? Because calcium has a +2 charge, oxide has a -2 charge, 2 goes here, 2 goes here, and it becomes Ca2O2, or you could just simplify it to CaO, all right? Realistically, it's just CaO. This does not happen, but we say this is how you can make a formula, all right? All the others must be wrong, and they are. Next question. The equation for reaction of magnesium with dilute sulfuric acid is shown. Magnesium plus sulfuric acid gives magnesium sulfate plus hydrogen. All right, so this is a metal plus acid reacting to produce a salt and hydrogen gas. Which mass of magnesium sulfate is formed when 12 grams of magnesium completely reacts with dilute sulfuric acid? All right. So they are asking what is the mass of magnesium sulfate forming when 12 grams of magnesium is reacting. So such a question is very easy. Now you could take two ways. In paper fours, we used to solve it in a 3 mark. Matlab, we used to solve it in a manner which resembled a 3 mark answer. Right. First, we would calculate out the moles of magnesium. All right. Then we would do analytical and comparative analysis. Right. In comparative analysis, we would just put mole ratio of whatever is given and whatever is asked, right? Whatever is asked, this is asked, okay? And then we would find out the moles of whatever is asked that would produce, okay? And then we would multiply it by whatever is asking. For example, over here, mass, it is asking about the mass, so we would multiply the moles of magnesium sulfate by the mass. Over here, we don't have to do that much. We can do a shortcut, and the shortcut is very simple. If you remember, magnesium has an AR of 24, right? Meaning 24 grams of magnesium produces 120 grams of magnesium sulfate. That is now something that has been established. 1 mole of magnesium producing 1 mole of magnesium sulfate, right? Everything seems to be balanced. Meaning 24 grams of magnesium producing 120 grams of magnesium sulfate. So 6 grams of magnesium would produce X grams. So X is going to be equal to, basically we are going to cross multiply. So X times 24 is equals to 120 times 6. So basically X is equals to 120 times 6 divided by 24. 24 and 6 get cancelled. 6 ones are 6, 6 fours are 24. So it's basically 120 upon 4, yani ke 30 grams. Oh, 1 second. Why did I use 6? Sorry, my bad. It is 12 grams. 12 grams of magnesium was used. Okay. So we're going to rewrite the whole equation then. 120 times 12 divided by 24. All right. 24 and 12, they get cancelled. So it is 120 upon 2, which is equal to 60 grams. All right. 60 grams should be our correct answer. Next question. An organic compound Q contains carbon, hydrogen, and oxygen only. Q contains 40.0% carbon and 6.7% hydrogen by mass. What is the empirical formula of Q? A similar question to this occurred in an O levels 2024 paper, I believe. The answer is going to be C3H6O3, but I'll show you how. All right, the empirical formula goes like this. So basically, you have to have the element that are mentioned in a ratio. Okay, so it contains carbon, hydrogen, and oxygen only. Okay, now out of it, 40% is the carbon. 6.7% is the hydrogen. They haven't told us how much percent oxygen is, but we know that we can subtract 40 and 6.7 from 100 to get the percentage of our oxygen, right, which is 53.3. Once we get the percentages, we divide them by their ARs. Carbon has an AR of 12, hydrogen has an AR of 1, oxygen has an AR of 16. 40 divided by 12 gives us 3.33. Okay, so this is 3.33 is to 6.7 is to 53.3 divided by 16 is equals to 3.33. All right, for 3.33. All right, now once we have done this, what do? We divide them by the smallest number to simplify. So basically divide everything by 3.33. All right, 3.33 and 3.33. All right, we get 1 is to, when you divide 6.7 by 3.33, you get 2.01. All right, basically 2.01 is very close to 2, so we are going to call it 2. All right, and 1. So the empirical formula is CH2O. All right, okay, CH2O. B is the correct answer. Okay, my bad. The O-level question asked us that its molecular formula was 90. So we had to calculate its molecular mass was 90. So we had to calculate its molecular formula from the empirical formula. So we had calculated it to be C3H6O. We don't have to calculate its molecular formula over here, just the empirical formula which we have. Next question. The value of Avogadro constant is 6.02 into 10 to the power 23. What is the total number of atoms in 2 mole of ammonia gas? Total number of atoms in 2 mole of ammonia gas. All right. Basically, total number of molecules first. Number of molecules is equals to Avogadro number Na multiplied by moles. All right. So this is equal to 6.02 into 10 to the power 23 times 2. Okay. When you multiply these two values together, you would get 1.204 into 10 to the power 24, I believe. All right, 6.02 into 10 to the power 23 times 2, that is equal to 1.204 into 10 to the power 24. All right, so these are the number of molecules. All right, now you're going to do one molecule. Oops, I'll do it with purple. One molecule of ammonia is NH3 equals 4 atoms. All right. So 1.204 into 10 to the power 24 molecules equals X. And now we always, just like always, we are going to cross multiply. X times 1 is equals to 4 times 1.204 into 10 to the power 24. All right. So basically, whatever our answer was, 1.204 into 10 to the power 24 multiply by 4. And we get 4.816. All right, so we get 4.816 into 10 to the power 24 atoms in total. All right, now the main problem with this question that we could not understand, or we may be getting confusion, was how are there 4 atoms? All right, first of all, this is NH4. I wrote NH4. This is NH3. All right, we're talking about ammonia. Ammonia is NH3, right? Ammonia gas is NH3. It has 1 nitrogen and 3 hydrogen, a total of 4 atoms per molecule. All right, so we found out how many molecules there were, and then we multiplied it by number of atoms per molecule. All right, so we get 4.816, which can be rounded off to 4.82 into 10 to the power 24. All right, so that is going to be our answer. Question number 13 then. 3 aqueous solutions L, M, and N are electrolyzed using inert electrodes. L is concentrated hydrochloric acid, M is concentrated aqueous sodium chloride, N is dilute sodium chloride. Which solutions produce a pale yellow-green gas at the end? A pale yellow-green gas resembles chlorine. All right. They're basically asking which ones produce chlorine. All right. So because this is concentrated HCl, right, it contains H positive ion at the cathode. All right, and then OH minus and Cl minus. Because it is concentrated, we'll see Cl discharge. So in L, we'll see Cl being discharged. All right, then the next one, M is concentrated. Once again, concentrated aqueous sodium chloride. It is Na positive and H positive on the cathode, and then on the anode it is OH minus and Cl minus. Because it is concentrated, once again chloride will discharge. All right, because we have discussed, we have studied that when there is a chloride, a bromide, or an iodide in an aqueous solution, we look at the concentration of that aqueous solution. If the solution is said to be concentrated, then the halides get discharged. If the solution is said to be dilute, then the hydroxides get discharged, like we'll see in N. N is dilute aqueous sodium chloride, meaning it is Na positive, H positive, OH minus, and Cl minus. The same ions as above, but because it is dilute, on the anode, OH negative ion will go. So this is not the correct answer. So L and M are the only two in which we will see pale yellow green gas being produced, meaning chlorine being produced. Next question, dilute sulfuric acid is electrolyzed using inert electrodes. What are the ionic half equations for reactions that take place at each electrode? First of all, you have to name the electrodes. The positive electrode is always the anode. Always remember, positive electrode is the anode and the negative electrode is the cathode. It attracts cations, the positive ions. All right, the negative electrode attracts the positive ions, therefore it's called cathode because positive ions are called cations. And the positive electrode attracts the negative ions, which are called anions. Therefore, positive electrode is called the anode. Okay. Now, we're talking about dilute sulfuric acid. It does not matter whether sulfuric acid is dilute or concentrated. We know that if we have a dilute sulfuric acid solution, the only cation is H positive. All right. Because there is no other metal ion. Sulfuric acid is H2SO4. When it is dissolved in water, right, it is going to produce H positive ions, it is going to produce OH negative ions, it is going to produce sulfate ions, SO4 minus. These are the ions that it is going to produce, right? So over here there is OH minus ion, all right, and then there is also the sulfate ion. Now, for a question like this, they're asking us what is going to happen at the anode and the cathode. Well, at the cathode, we know that electrons are going to be gained. So any one of this value is correct, right? It's either C or D. But now, which answer is correct? Okay. So at cathode, that happens, and at anode, we can see that sulfate does not get discharged whatsoever. All right. It's always the hydroxide. So which one is the correct answer? The correct answer is option C. Okay, hydroxide ions, they get discharged like this. Hydroxide ions, they make water, oxygen, and they lose 4 electrons. And hydrogen ions, they gain 2 electrons and make hydrogen. All right, so hydrogen and oxygen is produced, and this is how the discharge takes place. Okay. Next question, question number 15. Which statement about hydrogen oxygen fuel cells are correct? So, which statement about the hydrogen oxygen fuel cell are correct? They convert chemical energy into electrical energy. That is potentially correct. Okay. So, we can say that this is correct. Let's look at the next one. Hydrogen is reduced in a fuel cell. That seems to not be the right answer. In a fuel cell, hydrogen gains oxygen, therefore it seems to be oxidized. All right, so this statement is considered wrong. Next, they do not produce any atmospheric pollutants. Yes, this is very much correct. So the answer should be C. All right, 1 and 3 is correct. Question number 16 then. The reaction pathway diagram for the reaction between P and Q to form R and S is shown. Which letter represents the enthalpy change for the reaction? All right, so which letter shows the enthalpy change for the reaction? So obviously who? So obviously C, the difference between the energy levels of two platforms. All right, that is basically how you find out the delta H. This is delta H. All right. Next question. The equation for the complete combustion of methane is shown. CH4 plus 2O2 gives CO2 plus 2H2O. The table shows some bond energies. Okay. So we want to calculate out bond energies. Okay. This is a very easy question. This always comes. First of all, you're going to put the heading bond breaking. All right. And for bond breaking, what you're going to do is you're going to see how many bonds there are. So in CH4, you can see CH4 looks like this, right? Meaning there are 4 carbon hydrogen bonds. All right. So it means 4 multiplied by 410, that is 1640. All right. Next, we have 2O2. Now, O2 means this, and basically 2 of them. So basically 2 oxygen, oxygen double bonds. So 2 multiplied by 496. So it should be 8 less than 1000, right? So 9,992. But let's confirm. 496. Why are you off? Can you turn on? 492 times, sorry, 496 times 2 equals to 992. Yes, exactly. All right, 992. All right, you're going to add them together. All right, 992 plus 1640 equals to 2632. 2632. All right. Now you're going to put the heading of bond forming. All right. Bond forming contains carbon dioxide, CO2. CO2 means basically two carbon double bond oxygen. All right. Two carbon double bond oxygen, meaning 2 multiplied by 805. All right. So it should be 1610. 2 multiplied by 805. It is 1610. All right. Then we have 2H2O. H2O basically is made up of HOH and two of them, meaning a total of four hydrogen oxygen bonds. Four hydrogen oxygen bonds, four OH bonds. So this means 4 multiplied by what is the bond energy of OH? 460. So this should be equal to 1600 and 1840, right? 460 multiplied by 4. Yes, 1840. And then we are going to add the two together. 1840 plus 1610 equals to 3450. All right. Delta H is equals to, we're just going to simply say, let me put the heading of delta H first. Delta H. All right. So delta H is equals to bond breaking minus bond forming. This is equals to 2632 minus 3450. So 2632 minus 3450. The answer is minus 818 kilojoule per mole. This is our answer. B for ball. Okay. Question number 18 then. Which change is a physical change? Evaporation of ethanol. Yes. Physical change is a change in which no chemical reaction takes place. All these are chemical reactions. All right. Um, Next question. Which statement explains why increasing the temperature in a reaction involving gases increases the rate of reaction? So why does increasing temperature increases rate of reaction, increases the collision frequency between gas particles? That is true. It lowers activation energy. No, that is what a catalyst does. It increases the kinetic energy of gas particles. That also seems to be correct. It increases the number of gas particles per unit volume. Does it increase the number of gas particles per unit volume? We're not increasing the pressure, are we? We're not making the volume smaller. So this should not be considered correct. All right. So 19, the answer should be 1 and 3. All right. Question number 20. The equation for the reaction between ammonia and oxygen is shown. NH3 plus O2 gives NO plus 6H2O. Delta H is minus 909 kilojoule per mole. Which two changes to the reaction condition will both move the position of equilibrium to the right? Okay, so which will move the equilibrium position to the right? All right, so forward reaction is exothermic. We want to move to the right, so we should decrease the temperature. All right, and forward direction has 4 and 6, 10 moles of gas. Backward direction have 4 and 5, 9 moles of gas. So forward side has more moles of gas as well, 10 moles, right? And this side has 9 moles. So we should decrease the pressure and decrease the temperature. Decreasing temperature and decreasing pressure would shift the equilibrium in forward direction. That is 100% correct. Okay. Next question. Mercury 2 oxide HgO decomposes when heated. The equation is shown. Why is this a reduction reaction? All right. Why is this a reduction reaction? Oxygen is lost. There is loss of oxygen. That is the answer. Question number 22. Some information about two dilute acids is shown. Dilute acid is nitric acid and propanoic acid. Acid concentration, but the pH is different. Even though this has a higher concentration. Three statements about the acids are listed. Nitric acid has a lower pH because this associates more than propanoic acid. This statement is 110% correct. All right. So next, propanoic acid has a lower concentration of hydrogen ions in than the nitric acid. That is also true. Nitric acid has higher concentration because of complete dissociation. Propanoic acid has a higher pH because it has higher concentration. That is not correct. Propanoic acid is higher pH because it is a weaker acid. Okay, not because it has higher concentration. You can change the concentrations a bit as well. It will always have higher concentration. Next. Element E is a metal in group 1 of the periodic table, and element G is a non-metal in group 7 of the periodic table. Both of these elements form oxides. Which statement about their oxides is correct? The element E is from group 1, they should be basic. All right. And this is group 7. Both of these elements form oxide. So if this forms an oxide, it should be acidic. Okay. So oxide of E is acidic. No, 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 no. Oxide of E, the oxide of G is acidic and oxide of E is basic. That should be correct. All right. So this statement seems the best. Next question then. Lead 2 sulfate is an insoluble salt. Which method is suitable for obtaining pure solid lead 2 sulfate? Okay. So because this is an insoluble salt, right? This is an insoluble salt. So we should use 2 soluble salts. सही है? तो preparation by 2 soluble salts. In the notes, or when we wanted to write it, we always used to write, take the nitrate of the cation, meaning lead nitrate, and the sodium of the anion, meaning sodium sulfate. So lead nitrate and sodium sulfate, when they react together, they can produce lead sulfate. And then we filter the solution, rinse the salt that is collected as a residue, and dry it between 2 sheets of filter paper. That is one way. Let's look over here. Mix aqueous lead nitrate and aqueous potassium sulfate. Good. Heat to evaporate all of the water. Collect the solid when. Nahi, that is not. We do not need to heat and evaporate. Mix aqueous lead nitrate and aqueous potassium sulfate. Filter. Collect the filtrate. Crystallize. Then wash and dry. Crystallize. Not something I would want to do. Next, mix aqueous lead to nitrate and dilute sulfuric acid. Filter, then wash and dry the residue. This seems to be the most perfect one. Okay, let's look at D. Titrate aqueous lead to hydroxide with titrate. What are they on about? We can't titrate. We shouldn't titrate. Okay, we don't titrate. We just take two aqueous solutions of soluble salt. We mix them together and an insoluble salt automatically forms. So the answer should be C. Question number 25 then. The element oxygen and sulfur are in the same group of the periodic table. Which statement about oxygen and sulfur is not correct? They are non-metals. That is the correct statement. They have giant covalent structures. No, that is absolutely wrong. Okay. Next, question number 26. Tennessine is the bottom of group 7 of the periodic table. What are the predicted properties of tennessine at room temperature? A black solid, good. Okay. More dense than iodine. Yes, that is true. Okay, so the correct answer should be A, but let's look at the other ones. Part B says a black solid. Okay, good. More reactive than iodine. No. If it is below iodine, then its reactivity is less, because in group 7, reactivity decreases down the group. Okay. So reactivity decreases down the group. All right. I'll write like this. In group 7. All right. So color becomes darker. Down the group. Melting point and boiling point increases down the group. Well, this is all they were asking about, so we've written those points over here for those who don't understand. Question number 27. An example of sacrificial protection is the fitting of zinc blocks to the outside of a ship's steel hull. All right. Which statement explains why zinc is used to protect the iron in the steel from rusting? Well, how will zinc protect? It is called sacrificial protection. The method is called galvanization. Zinc is more reactive, yes, than iron, so it loses electrons more easily. Yes, yes, this is correct. Okay. So this should be A as well. We do not have to look at any other option because this is 100% correct. Which statement about alloys is correct? Alloys are harder than pure metals because they contain strong intermolecular forces. Well, we can keep it aside for now. Intermolecular forces is not something I like to use with alloys. Brass is an alloy containing copper and zinc, not tin. All right. So this is wrong. The different sized atoms in an alloy mean that the layers cannot easily slide over each other. Textbook sentence. Once again, C is the correct answer. Question number 29. Separate pieces of aluminum foil and copper foil are heated in air. The copper foil reacts to give a black solid. The aluminum foil does not react. Which statement explains these observations? Aluminum has an unreactive layer, but copper does not. Aluminum is below copper in the reactivity series. Copper reacts with moisture in the air, but aluminum does not. Copper reacts with nitrogen in the air, but aluminum does not. I'm sorry, my mind was somewhere else. So let me read the whole question again for myself. Separate pieces of aluminum foil and copper foil are heated in air. Aluminum does not react. Basically, why does aluminum not react? Aluminum has an unreactive layer. All right. Copper foil reacts to give a black solid, but copper does not. Okay, yes. This seems to be the right answer. Okay. Copper reacts because it doesn't have a barrier to protect it, but aluminum has a barrier of oxide which protects it. All right. Aluminum is below copper in the reactivity series. Garbage. That is wrong. Okay. Aluminum is very high in the reactivity series. Copper reacts with moisture in air, but aluminum does not. No, copper does not react with moisture in air. But if copper did react with moisture in air, we would have to coat copper with stuff as well. But as you can see, copper is just used as it is as well, right? In air, doesn't corrode. Which row gives which row gives the symbol equation for the formation of carbon dioxide and for the reduction of iron 3 oxide in a blast furnace? All right, reduction of iron 3 oxide and formation of carbon monoxide. Carbon monoxide is formed when carbon reacts with carbon dioxide to share oxygens, right? Because oxygens run out, there is scarcity of oxygen in the blast furnace now. So the carbon dioxide that is formed and the carbon that doesn't have any oxygens, they both decide that instead of one carbon having two electrons and the other carbon having no electrons, uh, they should have one electron per carbon. All right. So the answer should be either B or it should either be D. All right. Now let's look at the next one. FeO plus CO gives Fe plus CO2. It would have been considered correct, but this is not the ore iron, right? Ore of iron is Fe2O3, so the answer should be D for doctor. Question number 31 then. A sample of river water contains a high concentration of nitrates from fertilizers. Which statement about the river water are correct? It has a boiling point of 100 degrees. No. If it is impure, then it can't have fixed melting boiling points. All right. It turns anhydrous cobalt to chloride from pink to blue. No, from blue to pink actually. It turns anhydrous copper to sulfate from white to blue. Uh, that is true. Okay. So 4 is correct. But a second option should also be correct. Its melting point is below 100. Yes, this option we did not read. This option should also be correct. So the correct answer should be 2 and 4 D. Okay. In this one, they have swapped the colors. The color changes actually from blue to pink, not pink to blue, when water is added to anhydrous cobalt to chloride. All right. Next question: which statement about the treatment of domestic water supplies are correct? The water undergoes sedimentation to remove dissolved solids. Nope. Undissolved solids are removed. Undissolved large chunks of solid like silt and rocks. Okay. The water is filtered to remove insoluble solids. Yes. Then the smaller insoluble solids that do not settle down at the bottom, they are just suspended in water. They are removed by filtration. All right. Then the water is treated with carbon to improve the taste. Yes. Taste and odor improved by charcoal, basically activated charcoal or carbon. Simply, you can say carbon as well. So 2 and 3 should be the right answer. Let's look at the fourth option. The water is chlorinated to decrease the pH. The water is chlorinated to decrease the pH. Now the thing is, this statement is correct for the students of A levels, because in A levels we study that when chlorine is added to water, it produces an acid called chloronic acid or something like that. I have forgotten the name, but it's HClO. All right, hydrogen chloride basically. All right, so HClO, that is an acid that is produced when chlorine is added to water. Now the problem is it does decrease the pH, but it is not part of IGCSE or O levels, so I don't think over here this sentence should be considered correct. What for you guys the purpose of chlorination is, the water is chlorinated to kill microorganisms. All right, it kills bacteria. All right, it prevents infections, so this should be considered wrong. 2 and 3 should be considered correct because 2 and 3 are more accurate answers. All right, next, an experiment to find the percentage of oxygen in 150 centimeter cube of polluted air is shown. Damp iron wool measuring cylinder, 150 centimeter cube of polluted air. All right, the apparatus is left for 1 week in 150 centimeter cube of polluted air. After this time, the volume of gas measured is 122 centimeter cube. All right. Um, what is the percentage of oxygen to the nearest whole number of, in the polluted air? Percentage of oxygen to the nearest whole number. So volume of oxygen first is a very simple question. 150 minus 122. All right, so the answer should be 150 minus 122 equals to 1.22. What? I divided it, sorry. 150 minus 122 equals to 28. All right, 28 centimeter. Percentage O2 in polluted air. So we'll do volume.
Wait, sir,
Volume
why
at
are you subtracting the values?
Beta, the question is very simple. It says before it was 150 centimeter cube of polluted air. Now in the polluted air, there is also oxygen, right? Now iron wool reacts with steel. Okay, iron wool reacts with this steel. Okay,
Yeah.
iron basically reacts with oxygen, reacts with this iron wool, and oxygen runs out. So over time, the volume of air decreases. So where did the air go? 28 centimeter cube of the air was oxygen. It got reacted with iron. Okay,
Okay.
right. So now we have found out that 28 centimeter cube was oxygen. So volume of O2 divided by volume of polluted air. So percentage O2 is equals to multiply by 100. So this should be 28 upon 150 multiply by 100. All right. So what is 28 divided by 150 multiply by 100? It is equals to 19%. Basically 18.67 I'm getting, but to the nearest whole number it should be equal to 19%. So the answer should be A. All right. Next, question number 34. Nitrogen monoxide NO and carbon monoxide CO are both removed from the exhaust gases of a car by a catalytic converter. Which statement describes how nitrogen monoxide and carbon monoxide are removed by a catalytic converter? All right. the I'll write the equation for you. This is also something that has been coming in environmental chemistry quite frequently now. Basically, oxides of nitrogen, they react with oxides of carbon, basically carbon monoxide, to produce N2 gas and carbon dioxide. The equation is balanced by putting a 2 over here and a 2 over here and a 2 over here. All right. So everything gets a 2, and this is how you balance this equation. Okay, now what do you see? You see that oxygen has been removed from nitrogen and oxygen has been gained by carbon. Okay, so nitrogen monoxide and carbon monoxide are both reduced. That can't happen. All right, so nitrogen monoxide and carbon monoxide are both oxidized. That can't happen either. Nitrogen monoxide is oxidized. No, nitrogen monoxide is reduced and carbon monoxide is oxidized. D should be the correct answer. Question number 35 then. Propane 1-ol is oxidized by acidified aqueous potassium magnate in a similar way to ethanol. Which compound is produced by the oxidation of propane 1-ol with acidified aqueous potassium magnate? So propane 1-ol, what should happen? What is propane 1-ol? Propane 1-ol is CH3, CH2, C, H, H and OH. And what happens when you oxidize it with acidified KMnO4? What happens when you oxidize it with acidified KMnO4? It becomes a carboxylic acid. The alcohol becomes a carboxylic acid, right? So everything just stays the same, CH3, CH2, and C. Instead of the two hydrogens, now there is one oxygen and there is an OH, COOH basically, all right? So where does it say? CH3, CH2, COOH in D, all right? So this is CH3, CH2, COOH, all right? So that is shown in D for doctor, all right? Next question then, 36. The structural formula of methyl propane is CH3CH3CH3. The equation represents the reaction of methyl propane with chlorine. C4H10 plus Cl2 gives C4H9Cl plus HCl. Okay. How many structural isomers with the molecular formula C4H9Cl can be formed from this reaction? All right. How many structural isomers with the molecular formula C4H9Cl? So for that, we have to see how many structural isomers can have the formula C4H9Cl. Okay, so to do that can be formed from this reaction. All right, so here's methyl propane, and I'll have to draw all the carbons separately, right, and hydrogen separately. All right, now just one hydrogen gets substituted and one chlorine forms. All right, so we can have either the chlorine can be on this hydrogen, this hydrogen, this hydrogen, this hydrogen, this one, this one, this one, and this one, and this one, right? 9 of these hydrogens, if they are substituted by chlorine, they are the same thing. It means the same. Like for example, if the chlorine gets attached over here, it is same as the chlorine being attached over here. All right, or it is the same as chlorine being attached over here, right? Okay, because these three are all same types of carbons, right? The name will not change. Okay, so one of the structural isomer would be this. All right, and then we can just duplicate and minimize it, make it small. All right, and bring it over here, make it just a little bolder. All right, it could either be this, or we could have another isomer in which chlorine is on this carbon, which is different from all other carbons. All right, this carbon, which is different from all the other carbons, chlorine could also be over here. Okay, so these are the two places where chlorine could potentially be. Okay, so they would give isomers of one another. All right, like for example, now this structure, its name would be 2-methyl, because there's a methyl group on the second carbon. 2-methyl 1-chloropropane. 2-methyl 1-chloropropane, because chlorine is on the first carbon. All right, and this guy, it would be called 2-methyl 2-chloropropane. So 2-methyl 2-chloropropane and 2-methyl 1-chloropropane. So how many isomers in total? A total of 2 isomers. All right, there can't be a third isomer from methyl propane. All right, we could have more isomers if this carbon chain could be in a straight line, but they said that we are using methyl propane in the reaction, so C4H9Cl should be made from methyl propane. Okay, next, which statement describes disadvantages of manufacturing ethanol by fermentation? Disadvantages. All right, so the process uses a renewable resource. That is actually an advantage, not a disadvantage. The process produces impure ethanol. That is a disadvantage. We do not like impure ethanol. The process requires a high temperature. That is actually wrong. Process does not require a high temperature. So this is misinformation. The process is slow. Yes, that is a disadvantage. So answer is 2 and 4. Okay. Question number 28 then. Nylon is made in a polymerization reaction. Nylon is made in a polymerization reaction. Which row describes the type of polymerization and identifies the other product of the reaction? All right. So nylon, it is made in polymerization. Which row describes the type of polymerization? So this is a condensation polymerization. So answer should be C or D. Other product is water. All right. Other product is water. A smaller product such as water is produced. Okay, next question. Which ion forms a green precipitate with aqueous sodium hydroxide that dissolves in an excess of aqueous sodium hydroxide? The similar question came in October, November 2023, which we did yesterday's class, right? You added aqueous sodium hydroxide drop by drop until in excess and the sample dissolved, right? If it was Fe2 plus, it wouldn't dissolve in excess, all right? Cr3 plus is the green one which dissolves in excess. Calcium is actually white, it is absolutely wrong. Copper is blue, it is also wrong. Okay, so it would either be B or D. You had to remember which one dissolves. So chromium dissolves in excess sodium hydroxide and iron does not. Fe3. All right, next question. A mixture of soluble substances can be separated by proper chromatography. Each substance can be identified using RF value. All right, which formula shows how the RF value is calculated? All right, so which one is the correct answer is basically what they're asking. C and D, obviously, just by looking, they are wrong. It is always division, so subtracting is wrong, multiplying is wrong. Okay. Next, A. Look at A. Distance traveled by solvent divided by distance traveled by substance, wrong. Other way around. Distance traveled by substance divided by distance traveled by solvent. All right. Solvent comes at the bottom, substance comes in the numerator. B should be the correct answer. And with that, this past paper has been completed. I hope you guys have no questions.